Okay, we'll go ahead and get started. So thanks everybody for joining today. Today we're going to talk a little bit about infrastructure as code and enabling your Azure environment for multi-cloud. So my name is Brian Ashley. I'm a principal solutions architect here at Aviatrix. Formerly was at Azure as a global black belt for Azure networking. And with me today is Travis Mitchell, also a principal solutions architect. Travis is primarily focused on OCI. So today what we'll focus on is a little bit of just real quick background for those who may be new on Aviatrix. We won't waste a lot of time there. We'll stick to the meat of this webinar. But then talk a little bit about why should we care about multi-cloud, what is infrastructure as code, and then we'll go through a real world demo of what that looks like if in a real world scenario where we have to look at deploying some sort of multi-cloud infrastructure, but doing so with IaC. And with that, okay, we'll go ahead and get started. So real quick, as an overview of what Aviatrix is and what Aviatrix is not. Very often Aviatrix gets compared to some SD-WAN vendors of the world or private connectivity like Equinix, PurePort, Megaport, or even a SASE solution. That is not what Aviatrix is. We do work with all of those providers or solutions. However, Aviatrix in and of itself is a multi-cloud network and security platform. So Aviatrix orchestrates and automates a lot of the native cloud constructs, but really is a architecture that extends across all of the major cloud providers and provides cloud optionality. Now we have some tie-ins, as I mentioned, to those SD-WAN providers. We do work with and integrate with some of the private connectivity providers as well as the SASE providers. But all of those are connectivity mechanisms into the cloud, and then Aviatrix really takes over from there. So when we start to look at a general cloud environment, as we start with sort of the foundational piece, which is transit across and in between those clouds, that's where Aviatrix really starts to fit in. And then from there, we layer in advanced services within the cloud or clouds. So that could be networking services for those connectivity pieces, with some advanced services like granular route controls and those types of things. We have some security services that we will leverage and add on to, whether it's high performance encryption or some multi-cloud network segmentation. And then we also have some abilities for day two operations and visibility. So a big challenge is once we are able to deploy these networks, which we'll talk a little bit about today in the meat of the conversation with IaC, someone has to run them, right? And manage them day in and day out and troubleshoot them when they break. So Aviatrix has some components that make that easier, eliminate some of the skills gaps for our tier one folks, and bring some of those common troubleshooting tools to cloud environments. We also work with some third-party marketplace items as well for service insertion, next-gen firewalls, and we can orchestrate the deployment of some of those things. So with that, we do have some office hours or other webinars that we have done that really go through the platform as a whole in depth. But today, what we're really going to focus on is the IaC deployments and getting your Azure networks sort of ready for IaC in that multi-cloud world. So the first sort of step in this is, why do we care about multi-cloud? Why should you prepare for multi-cloud? Why is multi-cloud even a thing? When the initial sort of shift a couple of years ago really started with organizations going into cloud, it was very common for people to be in just a single cloud. It may have been a developer or development effort that was sort of in flight of things that were being built in cloud, but it wasn't sort of an enterprise or top level organization shift to cloud. It was maybe pet projects or things like that. So being in a single cloud just made sense and it was easy. Now, as we fast forward a couple of years and more organizations are moving to cloud, some of the lessons that we learned in the on-prem world, we're now relearning in the cloud world, right? Things like avoid vendor lock-in, or don't let the capabilities of your quote unquote hardware dictate your architecture, right? So now as organizations are moving to the cloud, we don't necessarily want to be limited by the tools that are just available in Azure, or just available in AWS or GCP or OCI. We want to run our applications where they run best. And that may be in Azure, that may be, you know, if it's a database, maybe that's an OCI. If there's, you know, maybe some machine learning, maybe we want to go to Google. Now, in addition to that, there are varying levels of coverage that happen when we especially look at a global environment. But even all of that aside, we run into many organizations all the time that say, you know what, AWS is a competitor of ours, so we're only going to be in Azure. We're never going to go anywhere else. We have our full deployment that's already there. We're set, right? What happens inevitably is it may not be internal organic growth that pushes you to multi-cloud. It may be a partner, it may be your customers, it may be some third-party integration, but inevitably what we're seeing is that a need for multi-cloud support will come. You know, it may be due to a merger and acquisition that has that somewhere, or a revamped web application that was built in another cloud, right? Or an executive deal, as we'll sort of talk through in our real world scenario, where you know, maybe at a top level, someone at an executive level decided, you know, we can get a better deal on our Oracle databases if we go from on-prem into Oracle Cloud. And so you, as the administrator or architect, have to figure out, okay, well now, you know, I've got everything working in Azure. How do I even begin to start in this new cloud? From a skills update perspective, from a feature and functionality perspective, how do I start to understand all the limitations that are associated with that cloud? So it's becoming just a more and more common thing, and architects are really having to plan for this for day one, even if they're only in one cloud today. So with that, I'm going to turn this over to Travis Mitchell to talk a little bit about IaC, and specifically what that looks like from a Terraform perspective, and maybe some of the other options in other clouds.
Thanks, Brian. So we're all here for an IaC discussion. I'm assuming that most of the people here on the call are aware of what Terraform is. I'll explain a little bit just to get everyone up to speed. So Terraform provisions infrastructure in all the major cloud providers. There's also the concept of a Terraform provider. Any vendor or software developer can write a provider, and Terraform will interact with that and interpolate APIs, manage state, create plans, etc. And you know, some of the Azure people on the call, you may be familiar with Azure ARM templates. If there's AWS people on the call, possibly CloudFormation. The main difference between those technologies and Terraform is it forces the user to have to reason with the outcomes of the particular script that they're running. Whereas with Terraform, you define your infrastructure as code, whatever variables that are going to drive that configuration, and then you can plan that configuration out and build the configuration, and then over time manage that configuration with changes to your code. So you're always aware of what the outcome is going to be. You have a record of what the state is going to be, and if there's any configuration drift over time, you can be aware of that. Terraform operates on all the cloud providers. Like I said, you can apply the changes with confidence. You know exactly what's going to happen beforehand. And our Aviatrix Terraform Provider sits on top of all of the CSPs. So what we allow you to do is abstract the complexity across any cloud provider. So if you're operating in Azure today and you want to operate in OCI tomorrow, using our Terraform provider, you can easily build and pivot and expand those networks into that new cloud provider and have some operational efficiencies there. Next slide, please. So this is a logical view of our architecture. At the top, you'll see our controller and co-pilot, centralized control, analytics, notifications, and then your data plane. And that center line there can span any cloud provider. You could build any of the objects or workloads that are needed for your particular environment. Now that fully managed encrypted data plane is going to have some basic characteristics that are and one of those main drivers is the Aviatrix multi-cloud transit. And from any region you can expand, you're obviously going to want to make sure that you're aware of latencies and whatever makes sense for your applications. And you can also move data up from your on-premise sites into the cloud using the same software in our orchestrated control plane. So what I want to focus on now, so everyone understands how our infrastructure as code works with the Aviatrix provider, is that control flow up over on the right. So you'll see our controller, and within an Aviatrix controller, you set up access accounts. These access accounts could be in any cloud service provider. And then when you make calls to the Aviatrix Terraform Provider, it uses those access accounts and programs the cloud service provider's APIs to build out the gateways, VNETs, program the routes, any site to cloud connectivity, any encrypted transit, insane mode, firewall insertion, all that is programmed from the controller. And there can be, any number of infrastructure as a service or PaaS services that you're going to be hosting workloads in for your business. So just to recap, we control at the API layer at all the clouds. Our provider understands what all of those interactions are. We abstract the complexity for our users. Enterprises really like that. And another key concept is a Terraform module. So a Terraform module is a group of configurations that are put together to drive a specific outcome. And that would be, let's say I want to build a transit or a spoke. I want to build a VCN, and I also want to build a gateway, and I want that in HA configuration. If I group all of that configuration together, I can put it into a module. And whenever I need to build something like that, I just call the module. And those modules are typically hosted up in Terraform registry. And you could think of that as a giant repository of modules that people contribute up to the registry. It could be vendors, it could be individual software engineers, and you can go grab a module from the registry, customize it, and get it running in your environment pretty quickly. Next slide, please. So here's a view of the abstraction, right? And up at the top, you'll see our provider. And beneath it, in each one of the swim lanes, you'll see the various bits of control that we have over all of the cloud service providers. So if we start over at the left, and let's say that your organization is invested heavily in AWS, and your environment's the way that you like it, and all of your team is experienced in AWS, and all of a sudden you need to pivot into another cloud. Well, we can help you with that because we can actually build that environment and scale you horizontally in any cloud provider. So companies that have a significant investment in one cloud can easily pivot into another cloud, and we can get not only infrastructure up and running, but we can get infrastructure that day two operations teams can actually manage, and we can program the routes, we can program the virtual networks, and all of the various other configurations. Okay, next slide, please. So here's a view of what a module would look like. So in this case, I want to build an Azure spoke, and I can build an Azure spoke with 10 lines of code. And these views on the right are from the actual Terraform registry. So they're designed in such a way that if I wanted to build one spoke, or if I wanted to build 100 spokes, the pattern would be exactly the same. It would be driven entirely by variables. It's very flexible. but it allows our customers to spin things up in a matter of days, sometimes even less. And down at the bottom, you can see a transit FireNet. So in this case, again, with about 10 lines of code, I can build a transit VNet with HA configuration, a VNG, a load balancer, and firewalls in HA configuration in a very easy way, right? And that, extrapolating that back to how much time and human error you would spend in a console, it's a very, very valuable pattern. Next slide, please. Okay, yeah, you can advance through all of these here. So this is just a view of what that code looks like, at a very minute level, right? And at the top level, we can see we're going to build a spoke on either side. In this case, Azure and AWS. We're going to build transit on either side, and then in the middle there, we're going to call the transit gateway peering resource, and we're going to peer those two transits. So with this view of code here, you can see that I've got workloads in AWS, I've got workloads in Azure, and now those workloads can talk to each other over encrypted transit. Next slide, please.
Okay, great. Yeah, so all of this is well and good. Now let's actually put this into a real world scenario and show this actually working, right? So let's say that for a lot of folks who are on the line, maybe you have a presence in Azure. You've taken the time to figure out all of the native constructs, how things work, what the limitations are, how to work around those, right? And you finally get everything working, and your boss comes to you and says, that's fantastic, job well done. We need to move faster, right? I mean, that's a lot of the reason why organizations are looking at IaC, is so that they can figure out how do we keep pace with cloud and take advantage of all the cloud services. So how do we do these things much faster? And oh yeah, by the way, the executive team made a deal with Oracle last week, and we're moving all of our production databases into OCI. So we need connectivity from everything that was just built in Azure to the OCI databases. And furthermore, security got involved in that conversation, and we need to do everything privately. So we're going to use some of the PaaS services now and refactor and leverage all the cloud managed stuff, but we don't want the publicly accessible pieces that come with that. Security says, nope, everything needs to be done privately. So at a moment's notice, now you have to figure out, how do we get multi-cloud support enabled? How do we figure out how to move quicker with things like that as infrastructure as code? And how do we do all of that privately? So these are the real world scenarios that we see from our customers all the time, right? And the reason why planning for multi-cloud from the very beginning, along with IaC, is so important. So with that, I'll be the boss, present that scenario to Travis, and we'll let Travis solve it.
Well, thanks, Brian. That's a pretty tall ask, but let's see what we can do. I'm gonna need to share screen for a second. All right, well, we'll get started here on the demo. Can you see my screen okay?
Sure can.
Okay, great.
Okay, so I've just got direction from the boss that he wants to see some workloads up and running between Azure and OCI. I think I'm going to use this repo. Looks like it's going to build a Aviatrix transit in Azure and attach some spokes in Azure and OCI with some test VMs and autonomous database. This is going to be the one we're going to use. So let me clone it to my machine and get started. So I've downloaded the repo to my machine. I'm taking a look here at the main.tf to make sure everything looks good, looks great. It's going to build Azure Transit spokes in Azure and in OCI. It's going to build some test VMs. It's also going to build some an autonomous database, which is great. My boss is going to like that. So let me take a look at the TFRs file. Everything looks good in here. These are the names that I've got defined in the controller. If I wanted to build a bunch of spokes, all I'd have to do is add more variables here. If I wanted more autonomous databases, I could do that here. If I even wanted to use some of the Oracle DBAS stuff, I could do that. So this is going to be great. I've added my SSH key, and I've also added the compartment that I want to build this in. The other thing that I've done is I've created two files. These are env files. And what these are useful for is setting your environment variables. So all I have to do is source this file in the shell, and I'll show you what that looks like. And that way, when I run the Terraform, everything is there. All right, I'm in the terminal in my directory. So now I'm going to source my environment variable files. And I'll source the Aviatrix one as well. And if I grep for my variables, I'll be able to see all of them here. So everything looks good. So now let's do a Terraform init. Okay, that looks good. Let's do a Terraform plan. Refreshing state. So we're going to go out and get all the data that we need. Okay, it's going to add 44 resources. That looks good. So let's get it kicked off. And now we're just going to sit back and let this run. This should take, we'll time it, but I'm going to speed up the recording. Should take about half an hour, 40 minutes, and we'll take a look at the infrastructure. Okay, about 40 minutes have gone by. Our provisioning is complete. Let's take a look at what we've got. So all this was created. Looks like my boss is going to be happy. I've got all of my infrastructures out there. Let's go take a look and see what that looks like in the Aviatrix controller and the cloud consoles. Okay, so here's a look at the Aviatrix controller. I can see all of my infrastructure has been created. We can come in and take a closer look, and we can see that I've got all of my peering set up. It looks like I've got connectivity with my OCI spoke. That looks great. Let's take a look at all the gateways that were created. Wow, that's a lot of them. So we've got 10 gateways that were created, all of them with HA configuration, which is great. So we don't have to prove that for the boss. And let's take a look and see what the transit looks like. So I've got transit in Azure, and I've got spokes in Azure, and I've also got my autonomous database spokes out here. I've got test VMs in each one of them. So now all I have to do is take a look at the output from the Terraform and provide those IPs and the credentials to my application team, along with the database wallet that's also created in the same directory. And now my application teams and my boss can go ahead and start testing connectivity between workloads between the two clouds. All this is done in about an hour, and it's easily repeatable, and again, can easily be expanded into any cloud and scaled out as much as you need based upon the variables that you put in. Here's a look into the Azure console. In the resource group we created, we see all the infrastructure there. And in OCI, we can see our spoke instances, and we should also be able to see our autonomous database as well. Well, wrong compartment. We'll go into the database compartment, and there it is. So there's our autonomous database. So now we've got Oracle data sources in OCI, we've got Azure infrastructure in Azure, and we've got full transit connectivity, visibility, control between both of them, all built with Terraform in a very short span of time.
Yeah, no, Ms. Page. Today's a training day, oh boy.
All right. So, Brian, boss, are you there?
I'm here, sir. Well done.
Yeah, so it looks like we've got everything up and running. I think you can tell our POC team that we've got full eyes on the infrastructure. We'll turn over the database wallet and all the IP information so they can get their infrastructure up and running.
Fantastic, sir.
Great. I'll stop sharing and I'll turn it back over to you.
Okay.
Okay, so this is the MVP that we just built, right? This image is taken from the repository. It's pretty simple. You can see that in this case, we've just got a transit in Azure, and we want to test some workloads in OCI, and that's built privately, so that autonomous database is attached by an NSG with a private IP in the private subnet of that particular spoke, and the little screenshots on either side are just showing that, from both test VMs, I can see across, right? So, without getting into the details of, how do you connect, how do you connect the applications and configure them? The key takeaway here is that, essentially the environment's ready to turn over to application and project teams. Next slide, please. So, if this were going to be a production topology, things, the code would not grow in size significantly, but we would just add some different features on top of it. And those red and blue boxes represent multi-cloud segmentation. So in the real world, you may have certain development database environments, and you may have, let's just say prod and non-prod, and you could look at those with the red and blue color codes. And you can easily, not only in Azure and OCI, but in other cloud providers, you can enforce logical control without any code using security domains within Aviatrix and enforce that control, right? And if you tried to do that yourself in the cloud service provider, it would become very complex, and once you cross cloud boundaries again, it would become very difficult. And that green line on the bottom represents our multi-tier transit. So as you expand, you can go across regions, overcoming native cloud service limitations. I know in OCI sometimes there's challenges spanning regions, but we kind of address that and overcome it. And if your project team or my boss Brian decides that for some reason he wants to try out BigQuery next week, that's not a problem. We can spin this up with the same amount of effort, but this is what that would look like in a prod topology. We would have security domains, and potentially we would have some firewalls in that transit layer as well. Next slide. Okay, so all of the stuff that we saw here, I kind of advocate the standard enablement path. So maybe you're you're new to Terraform, HashiCorp has a great Learn HashiCorp or Terraform track. If you kind of follow your nose on that one, and the breadcrumbs are great there, and you can get a good understanding of the concepts and some of the practical implementation. A lot of people have familiarity with Terraform. Another thing I recommend, even if you're not planning on getting certified, if you get the Udemy practice test, it's about $20. You can just look at the practice questions and kind of derive from that what's important and what's not, and what HashiCorp views as important concepts. So that's another useful tool, not necessarily top of mind, but something good to get familiar with Terraform and infrastructure as code. You can learn Git basics. You don't have to learn complex branching and all of those types of things on day one. If you can find a repository and clone it to your local machine and start to make some modifications to get it to run, that's good enough usually. Take a look at our Terraform modules on the Terraform registry. You can search and find those out there. They're being added to all the time. We're actually going through a refresh cycle to support the recent 6.4 release. Visual Studio Code is your friend. If you're going to be doing any type of work with code, recommend getting that installed and putting the Terraform extension on there. It's got a really nice code linter, and it will format and check everything for you. Again, the registry and that HashiCorp link there, they maintain some workshops, and that's kind of a dynamic URL, but any of their technologies that you're interested in, specifically with this talk around Terraform, you can go out there and take a look at that. And the MVP demo that we ran through today is public, and the URL for that is right there. Next slide.
Okay, great. Yeah. So, but before we wrap up here, we do have a few questions, Travis, and I'll take a couple. Maybe you can take a couple. So one of the questions was, when you use Terraform to create your Aviatrix-based infrastructure, where do you maintain the state file? Is this state file stored in the cloud or somewhere else?
Yeah, so so if you're just getting started, you're probably, your state file is going to be local to your laptop. As you get serious, you're going to want to think about your backend, and the backend is where Terraform maintains state. So depending on what your primary cloud is, you could store that in blob storage in Azure, or a bucket in another cloud. And Terraform is smart enough to know to go out and look in that bucket and maintain the state there from wherever you're running it. Additionally, you can also use Terraform Cloud, and Terraform Cloud is a HashiCorp hosted product that is really good for collaboration and also managing state. So that's where you're going to want to manage state. It's not going to be on your machine. It's too much risk, but you're going to want to put it into a bucket, most likely, in a cloud service provider, and you're going to want to turn versioning on that bucket. So if you ever need to roll back state to a point in time, you'll be able to do that.
Okay, great. So next question, and I'll take this one. What physical pipe is used between Azure and Oracle to make those private connections, the multi-tier transit, and how is that cost determined? So the nice thing about Aviatrix as a solution is that it's a great mix of underlay and overlay capabilities, right? So when we talk about just in general connecting Azure to OCI, obviously we could do that with public IP, IPsec tunnels. We could do that with, if you have a fast connect and an express route circuit, there's some native integrations there that would allow that communication. Or let's say you were using an Equinix provider where, again, you have that fast connect and express route circuit. There's ways that that provider can bridge that communication. Now, from an Aviatrix perspective, essentially, we see all of those paths as underlay, but available paths to us to build our connectivity across. So essentially, Aviatrix can take advantage of all of those paths at the same time. Now, what we see from most customers is that they want to do that, but maybe AS path prepend across one or the other, so that, let's say they want to use, in our case, right, the security folks said we want to keep everything private. So maybe we have Express Route Fast Connect and the interconnect that comes natively between Azure and OCI. Let's say we build our transit tunnel from Azure to OCI through that path. However, we also want a backup path in case anything were to happen to either one of those circuits over the internet via IPsec. We can build those simultaneously and just AS path prepend over the IPsec, or excuse me, the internet path. That way it's available to us when and if we need it. So that's one of the real nice things. In terms of pricing, that's often a rabbit hole because there's obviously some Aviatrix pricing and some underlay pricing and all that kind of stuff. So I'll just sort of talk in general. From the Aviatrix perspective, we have metered and term licensing options. In the metered version, that tends to be based on tunnel counts. So depending on how many tunnels we build, whether it's from a hub to a spoke, or in the case of our example, from transit to transit, then there's HA that comes into that for redundant tunnels and all those kinds of things. There are some underlay costs there, whether it's through the interconnect between Azure and OCI, or Equinix if we're routing privately that way. There may be some additional costs there, but throughout any kind of engagement that we do with customers, any POC or production deployments, those are all details that we talk through and put together a real good pricing structure so that all of that is sort of well known. Okay, one other question, Travis, I'll give this one to you. So if we were to, instead of OCI, we were to connect in GCP or AWS, how similar is the configuration in terms of like peering or applying NSGs and next-gen firewalls?
It's so when you're using our Terraform modules out on the Terraform registry, the patterns are pretty much the same. The variables, are going to be, account name and CIDR, but we only expose the tip of the iceberg to the users, right? So any of that complexity, those implementation details with the particular cloud service provider, we abstract that from you. So a GCP transit module looks almost exactly like an OCI transit module, and the same goes for AWS, right? And the challenge becomes, and it's not a hard challenge, is it's really then an assembly operation. So it's a matter of cycling through, determining, okay, what is my MVP going to look like? What clouds do I want involved? How do I want my workloads to be distributed? And then what modules do I want to put in place to assemble that? And typically, even with, if you're that customer that's operating in 4 clouds, we're still looking at a relatively small code base, right? And I'm talking about, hundreds of lines of code max, not thousands of lines of code and deeply nested modules and dependencies and things of that nature. So once you take a look at the repo, you could look at the one that we ran through today, and then take a look at some of the modules in our registry. You'll be able to see that pattern and how it repeats and how this essentially just becomes an assembly operation.
Great. Okay, I'll do one more question and then we'll wrap up here. So another question was, your solution is very focused on the public cloud. How about on-prem, DC, or private cloud? That's correct in a general sense. Aviatrix as a platform is really designed to live in the public cloud environments. However, that being said, we recognize that there are, on-prem to deal with, there's own private clouds, but even within the CSPs themselves, there are pieces that are a bit of a managed service or private cloud, right? One example in Azure specifically would be like AVS as a solution. So in those instances, we actually take our gateways and we have some virtual versions of those that we can deploy inside of like an ESX guest. And same would be true within a private cloud or potentially on-prem. Today, we also have it's the only physical piece of hardware that we make, we call it Cloud N, but it allows for the high performance encryption of those private circuits. This is in addition to that, where we would have a virtual gateway that could be deployed inside that hybrid cloud, inside an AVS environment, as an example, to provide that same type of connectivity and extend that Aviatrix control plane and functionality down into those locations. Okay, great. So we just put up a poll as well. Would appreciate everybody's time and taking to fill that out. But in addition to that, we've got a couple of ways to sort of get started with Aviatrix if you're interested. So we have something called a sandbox starter, which is it's all programmatically deployed. It's a bit of a follow your nose type of lab environment, but it essentially allows you to kick the tires with Aviatrix and build out a complete multi-cloud topology, all in an automated way within your own environment that you can kick the tires on and actually start to see Aviatrix in action. It's costs about $1 an hour. And again, it's all self-contained, but is yours to play with. So if you want to find out more information about that, we have links in our community site, or you can send an email to info@aviatrix.com. In addition, if you would like to follow up with us and have some architectural conversations about your specific environment, we have some customized architectural design sessions that we do with our solutions architect team, folks like Travis and myself, where we will work with you and your organization and whether it's in person or because we're still all getting vaccinated, if we need to keep it virtual, that's fine. But we can start to get away from the high level stuff and really tailor something towards your organization and your challenges. In addition to that, Aviatrix also has a certification program. It's the ACE Multicloud Networking certification. We have self-paced or instructor-led. We have several different modules, from a basic 101 getting started, where we teach a little bit of the cloud 101s across all the clouds, as well as some basics on Aviatrix, up into our pro version, where we dive very, very deep into the Aviatrix platform. We also have some paths that are dedicated to operations folks. It's a really, really good program if you want to check that out. And with that, I will turn it over to Tammy.
Vicky, yep.
Vicky, I'm sorry.
we're interchangeable.
That's right. That's right.
So thank you everyone for attending today. Thanks, Brian and Travis. That was great. So yeah, also I popped up a couple of the next couple tech talk topics. The first one on the May 18th, we're talking about network and security design considerations for paused databases. And then on May 25th, a deep dive for network engineers into BGP and public cloud. So there's a couple upcoming topics. Also, as Brian mentioned at the beginning of the webinar, we also have a new event every Thursday, 8 a.m. Pacific time, office hours. If you want an overview of what Aviatrix does, and then we open it up for live Q&A. It's just 30 minutes, but I put the link in chat, so please feel free to join us there if you'd like a high-level view of Aviatrix. So thank you for attending today. Have a wonderful day. Thank you. Bye-bye.